Here is a quick lesson on a couple of important triangles we're going to be using in this class. So if you look at the worksheet that you will complete later, it says the shape below is a, hopefully you look at it and you say this is obviously a square. It has 4 congruent sides and 4 right angles. It tells me if each side of this square is 1 unit, 1, 1, 1, 1, calculate the length of diagonal AC. So I will go ahead and I will draw AC. I want you to think for a second how I can find the length of AC. Hopefully you're thinking to yourself, well, right here I have a right triangle and you know 2 side lengths and you want to know the third. So, Pythagorean theorem to the rescue. I end up with x squared equals 1 squared plus 1 squared. So I solve x squared equals 2. And then to get x, I take the square root of both sides, and I get that x is equal to the square root of 2. Okay, so what we have here is an isosceles right triangle. Isosceles because 2 sides are the same length. And what I want you to think about is, what are these 2 measures? Those 2 angles, here and here. Hopefully, you're like, oh, 45 degrees each. So, what we have just come up with is what we're going to call the 45, 45, 90 special right triangle. And what I want you to know about this right triangle is the side lengths won't always be 1, 1, rad 2, but they will always be in the ratio A, and then A, rad 2. So, for example, if I told you that this side A was 3, you would know this was 3, and then this side would be 3 rad 2. Okay?
3 rad 2 is 5.
That was my daughter. Okay?
Who was that?
Can you just go watch TV for a second?
What was that?
I'm almost done. Okay, so this ratio holds true for all 45, 45, 90 special right triangles. Okay, I'm going to do 2 examples, and then I'm going to let you guys do the rest on your own. If I look at example 1, I notice it's a 45, 45, 90 triangle. 45, 45, 90 right triangle. So I know that the ratios of the sides are going to be in a like A, rad 2. So here, A is 8. A is 8, which means that side X will be A rad 2. And if I know the A is 8, I get that side X is 8 rad 2. Okay? I'm going to do one more example for you. And then, like I said, I'm going to let you get some practice. Now, with this one, I know that the ratios are A, this is A rad 2. So you have to work in reverse here. I know that 18 equals A rad 2. So that means that if I divide both sides by rad 2, I get that 18 divided by rad 2 equals A. This is an absolutely correct answer, but what you've done in the past is rationalized this fraction, which just means I don't want a radical in the denominator. So in order to rationalize this, you're going to take the 18 rad 2 and multiply, hopefully you remember this from Algebra 1, if not, you guys let me know. Multiply both sides by rad 2 over rad 2. And why am I allowed to do that? Because rad 2 over rad 2 is just 1, and I'm allowed to multiply anything by 1. What happens here is I get 18 rad 2 divided by 2, which simplifies to 9 rad 2. So, what I have is this, absolutely correct answer. In case it needs to be rationalized, you know, if you're looking to match it to a multiple choice on a test, you might need to show it that way. Okay? I know that was quick, but a lot of this was review. If you have any troubles, you let me know.